Report. Hello. Am I audible?
Yes, sir. Yes, sir.
Good morning to all. Uh, okay, for this subject, mostly mechanical students have registered, right? Uh, I have a question to mechanical students. If they studied IC engine in their syllabus previously. Hello?
No, sir.
No, no. Okay. So I will start with IC engines, right? Basics of IC engines, and then we'll proceed. Uh, all of you got the link, right? And you connected from the link. This link will be a common link for all the lectures. Hello?
Yes, sir.
Yeah. Uh, Today we'll start with what is IC engines and how it operates. I have a few videos, right? I downloaded those videos from YouTube itself and a few of them from NPTL, right? Uh, at the end of session, I will share the link from where I downloaded the video, right? And those video is uploaded. That means the whole lecture video is I'm going to upload on Google Class, right? So let's start with IC engine. Slide is visible, right?
Yes, sir.
Okay, okay, okay. Sorry. Uh, Before starts with the electrical system used to control the automotive system, right? We should know uh, uh, what is the automotive system and how the automotive system is driven, right? Uh, there are many process happens inside the automotive system, and those are divided into sections, right? Basically, um, the mobility of vehicle is a continuous process, and there are many modules which are running one after the other, right? So we'll see one by one all those modules and how the automobile moves, right? Uh, the end goal of automotive system is to drive a vehicle, like driving a vehicle or steering a vehicle, right? Steering and driving both are different. Steering is a mechanism which steers, means change directions uh, according to the requirement. Driving, which moves the vehicle, right? Or uh, which is nothing but a mobility of vehicle, right? uh, in combination with these two, one more we have braking system, right? And to get the comfort inside the that automobile, we have suspension systems, right? So there are a lot of modules which are working behind automotive systems, right? So we'll go one by one. uh, the main or backbone, we can say powertrain, right? Now what is powertrain? Basically powertrain is nothing but the prime, it is a prime mover. Prime mover means which moves the vehicle, right? So to move the vehicle, we need a power, and that power is generated through a internal combustion engine, right? You'll see there are different types of engines available, and how those engines are used in automobile, right? To get the mobility. Uh, there are two types of internal combustion engine. One is conventional powertrain, and second one is electrical and hybrid powertrain, right? Now, in conventional powertrain, we have petrol, diesel, and gasoline types of engines, right? And nowadays we have electrical and hybrid powertrains, right? uh, which is not which are not using internal combustion types of process, but still in hybrid cars those are attached with the conventional powertrains, right? Now if you know, there are different segments of car, right? Segments means according to the engines which is installed inside the now we are talking about four wheelers, so we'll take an example of car, right? Am I audible? Am I audible?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So
Yes,
whatever
sir.
we learn in this subject is based on the engine, and that is four wheeler engine, right? And best suitable example is the car, right? It might be a luxurious car, or it's normal car, right? Now let's start with the car. We have different segments: petrol engine car, diesel engine car. We have a gasoline, means CNG, and its LPG types of car. Then we have electric hybrid cars, not electric, hybrid cars, where those are driven with means once they uh, once they achieve steady states, then the ignition system is driven by the electric uh, motors, right? And that types of cars are called as hybrid cars, right? Then we have a few more hybrid cars like gas and like LPG and LPG or CNG with combination of petrol and diesel, right? That sort of the hybrid cars we have. And nowadays we have a car with uh, that those are driven through batteries, right? That means electrical power. Got it? So there are different engines, and there are different designs of those engines, right? Which drives the that particular vehicle, right? Uh, while driving, we like there are two parameters which are controlled by the driver, right? So the parameters of engine which are controlled is through a clutch and gearbox, right? So these two parameters uh, are the major parameters of engine, okay? And these parameters are control parameters, right? Then we have one more system which is called as brakes, right? There are different types of brakes technologies available inside a car, right? Hydraulic brakes, air brakes, right? Hydraulic brakes, as we know, in hydraulic we uses oil as a supplement, or as a prime braking system, right? So controlling of oil levels, or the pressure of oil levels is used to brake the systems, right? uh, if you remember, in a truck or heavy vehicles, instead of hydraulic brakes, air brakes are used, because those are very efficient controlling to compared to the hydraulic brakes. Hydraulic brakes, we know the difference between hydraulic and air, right? Pneumatic and hydraulic, you know, advantages advantage
Yes,
of
sir.
hydraulic systems and
Yes, sir.
yeah. So if we want a very fast response, then normally we go for pneumatic systems. If we need a slow response, then we normally go for hydraulic brakes. Uh, so in a heavy vehicles, the braking system is designed with the pneumatic system, right? Like air brakes, uh, as well as in uh, passenger vehicles or light motor vehicles, we normally go for hydraulic types of brakes, right? Uh, Now it's total depends on how much types of vehicles you know, right? And there are different segments of vehicle, right? Uh, if you if you know four wheelers, in four wheelers we have uh, light motor vehicle, then we have uh, one more segment which we call tempo traveler, which is basically private, comes under private sorry, passenger vehicle, right? uh, then we have trucks, right? And in trucks again we have different versions, right? And there is a number. If you go for Tata or Ashoka Leyland or something other else, right, they have a different naming, right, or notations for their trucks, right? And that depends on how much load they can carry, right? Now for such heavy vehicles, we normally preferred air brakes, because they are they have a huge load. They carrying huge loads, right? Whereas these passenger vehicles, means cars, they normally loaded with a small load is like they're traveling with small loads, right, compared to the trucks, right? Now brakes are the brake is a major system which is required to stop the moving entity, right? uh, Now whenever we apply a brake uh, at a very higher speed, that means if the car is moving at a very higher speed, and if you applied a brake, it may get toppled, or it may get what we call the tires get slipped, right? uh, Means they get tilted, and
Skid, sir.
yeah,
Skid.
skid. The skidding is the skidding operation is dangerous, right? When the car is moving with the higher speed, and once we apply brake. So to avoid such uh, skidding, we use anti-brake systems, right? Now in anti-lock brake system, the brakes are applied intermittently, right? So that the wheels remains in same position, right? Means same direction. They never skids. We have a video on this ABS, and we'll discuss how the anti-lock brake systems are achieved, right? Then we have a steering mechanism and wheel alignment, right? Now wheel alignment is important to like wheel alignment is a major parameter uh, which keep the vehicle in a particular direction, right? Now steering mechanism which is used to choose the direction, right, and to drive a vehicle in a particular direction, right? On With the steering mechanism we have a cruise control type of controls provided, right? Nowadays, those are available on steering mechanism, right? Then we have a suspension which uh, under which we are going to discuss how the suspension is achieved, right? Now this syllabus is totally based on the I have taken these slides from NPTEL course, right? And these slides uh, uh, sorry, this lights is a part of automobile sector only. It's not electrical vehicle, but our syllabus is mostly oriented towards uh, controlling part of automotive sector, right? So uh, uh, electronics control for the automotive vehicle, right? Then in our syllabus we have a topic based on the tire pressure, right? So I will go through that, right? Now let's start with what is IC engines basically. Uh, the full form is internal combustion engine, right? Now internal combustion means the combustion means petrol and sorry, the gas or the yeah petrol gas or diesels, right? Those are combined with the air, right? And the combustion is happen inside a chamber, okay, where the pressure the heat is produced, and that heat is that as we know, as heat generates, it expands, right? So it generates pressure, which is that thermal energy, which is converted into kinetic energy, right? Now this in internal combustion engine, there is a two tuple process. The chemical energy of fuels is converted into thermal energy, right? So that means those are ignited and a thermal energy is created, and this thermal energy is used to drive the pistons, okay, which are attached to the crankshaft, and automatically that crankshaft rotates, right? So this is a two tuple process, right? uh, Chemical energy in a fuels, right? Fuels means gasolines, right? These are used to these are ignites, and which is converted into a thermal energy, means heat, and that heat is used to drive the crankshaft. That's why it is called as heat engines. IC engines also called as heat engines. Basically, IC engines are part of, or is a classification of heat engine, right? Where the heat is used to drive the automobile, the vehicle, right? Uh, there are two types of heat engines: external combustion engine and internal combustion engine. In external combustion engine, the combustion part is achieved. That means this process, process one, and this is process two. The process one is happens outside the. That means there are two parts in external combustion engine, right? This process is happen in one part, and this process happens in another part, right? And these both are linked together. An internal combustion engine, both the processes are happen in a single part, right? So that's the difference between external combustion engine and internal combustion engine. One more difference is uh, the conversion of heat. That means the conversion, which is chemical reactions from which the heat is generated, that happens in one part, and that transferred to the other part, right? And in another part, we whatever energy is received, that means that is used to drive the uh, or mobile, the vehicle, right? Here we use the best example of this is steam engines, right? Which is used in railways, right? uh, Nowadays these are absolutes, right? Only these types of engines are used in various vehicles, right? Uh, in internal combustion engine, petrol and diesel, then nowadays we have CNG, LPG, those are combined with the air in a combustion chamber and ignited, and then thermal energy is produced uh, in the same cylinder. In the combustion chamber we have attachment which moves the crankshaft, right? I will show you how that happens inside the internal combustion engine. I have a video, right? So after this two slides, I will show you the video how that happens, right? Uh, these engines, right? Internal combustion engines, it may be driven by petrol or diesel. There are two types of engine. One is reciprocating engine, and second one is rotary engine. Now, this is reciprocating and rotary is based on how the movement is happen. Uh, Whenever a kinetic energy is produced and it is used to drive the uh, is to drive the main crankshaft, right? For that, how the uh, uh, that movement is achieved, according to that we have two types of engine. One is reciprocating engine and second one is rotary engine. uh, this is one kill engine, and here the reciprocating engine we have petrol and diesel engine, right? uh, Now the petrol or diesel, right? These fuels are combined with air, and then ignition is provided, right? Ignition means a spark is provided, right? To come to get the combustion of these two, right? We need to we need a spark. We need a spark so that the petrol and this air uh, they combine and ignite, right? So according to ignition, we have spark ignition engine and compression ignition engine. Now spark ignition engine is a very high voltage spark is used to ignite the combustion like a petrol engine, right? Whereas in few diesel engines, okay, a compression ignition is used, right? That means uh, a large volume is taken inside the combustion chamber, and then very small spark uh, can be used to uh, combust these two, right? Now combustion, how the combustion is achieved is through uh, two. One is basically petrol or a diesel or any other fuel. They have a chemical, they made of chemicals of hydrocarbon, right? These are mixed with oxygen, okay? And there is a proportion to mix these two, uh, uh, we can say these two fuel and air, right? And when we uh, supplied those fuel and air in a proportion or in a ratio inside the combustion engine, then only a proper heat is produced, right? Which is used to convert into kinetic energy, right? Uh, the mechanism, there is a separate mechanism required to inlet these two in a quantity, right? So there is a feedback which previously achieved through a mechanical assembly. Nowadays this is achieved through electronic circuitry, right? How much proportion is needed to drive a car with a particular speed, right? So this combustion, so this combination is decided, it is controlled, initially it is controlled through a mechanical types of mechanism, and nowadays electronic mechanism we have, right? So if you remember, a Bosch company which developed, which atomized the engine, right? Bosch, everybody know Bosch company, Robert Bosch company. Hello, am I audible?
Yes,
Yes,
sir.
sir.
Yes,
Yeah,
sir.
yeah, yeah, yeah. So I don't know how many of you know, basically the major invention in uh, atomized atomization in engine, right, is achieved by Bosch company, right? And we have in India we have Robert Bosch company in Nashik, right, in Maharashtra, and in Karnataka, in Bangalore, right? The like in Nashik, we the Bosch company developed different tools, right? And the engine assembly is done in Bangalore, right, in Karnataka. This is the major company which developed different automation, right? And they have a lot of patents, or they hold a lot of patents about the automation of engines, right? Based on the strokes, strokes means how many strokes are achieved inside the combustion chamber. Yeah, combustion, whenever combustion happens. So obviously, there is a compression and decompression of piston, right, with respect to the assembly. So this the movement of piston, which is attached with the crankshaft, right? So depending upon the strokes, we have 4-stroke engines and 2-stroke engines. Like a crankshaft is totally rotated, means 360-degree, right? We need a 360-degree rotation. So this 360 rotation is achieved with 2-stroke only. Here we achieved it with 4-stroke, right? So we'll have this video, right, after this 2 points. Naturally aspirated engines and supercharged engine. Naturally aspirated engines, in which a normal air is taken inside the chamber, right, combustion chamber, and then the mixture is burned, right? Whereas in supercharged engine, a compressed air is taken inside, okay, and then it is burned, right, with the fuel. Now the power which is generated in supercharged engine obviously is more compared to the naturally aspirated engines, right? The best example is the turbochargers, right? Whenever you go with these terms, right? If you go for purchasing a car, you will find out turbochargers engines are available nowadays, right? Those are very similar. Only one part is additional in turbocharger, which is uh, air compressor, right? So this air compressor increase the volume inside the combustion chamber. Obviously, the energy which is generated inside the chamber will be more compared to this, right? That's what the difference between these two. And cost wise, if you checked, obviously this is more than this, right? uh, the best example is suppose we have a new car, you know, or you take Kia Sonet, or you go for Brezza, right? In both of them, if you check the cost of these two, you will find at least 2 or 2.5 lakhs difference between these two, right? One is supercharged, right, turbocharged, and one is naturally aspirated. Normally these engines are 1 liter, 1.2 liters types of, right? And here we have less than that. Basically it is 1.2 we say. Here we have 1 liter, but turbocharge, what it does, it generates a torque which is more than this, right? Then we have a components, right? Different components. Uh, this is cylinder block, right? 4 chambers are available, and there is a common rail above to this. Common rail means a crankshaft rail, right? Uh, Sorry, crankshaft is here. Here we have a common rail from where we inject the fuel, right, and air. So there is an inlet section as well as outlet section, right? So we'll see that inlet and outlet sections. Before that, it's better I will show you a video, right? I will show you video so that you will understand all these blocks, right, or components. Wait a moment, right? Is this video, hello?
Yes, sir.
Yeah, is it visible?
It's visible.
Yeah, yeah. So I'll share audio with this because they have created a beautifully.
It converts the explosions that
This is the
occur
engine.
inside its combustion chambers into motion. The aim of this engine is to use this energy to provide movement and transfer it to the wheels so that the vehicle can move. It all takes place inside the cylinder. Here, we can find the combustion chamber where the explosions occur.
Okay.
The cylinder is basically the space through which
Combustion chambers are not shown here, but there is a assembly, right? This whole assembly is inside a big assembly, right? Which already I shown you.
the piston travels. The purpose of the piston is to transfer force from expanding gas in the cylinder to the crankshaft via a piston.
Okay, this is the crankshaft, right? And these are the pistons which are attached to the crankshaft, and this crankshaft drives the wheels, right? So the power of this is transferred to the wheels, right?
Rod or a connect.
These are the inlet and outlet valves, right? From one side, a mixture of air and fuel is inlet to the that is drives inside the combustion chamber, and one is the outlet valve, right?
rod, so that the back and forth linear motion of the pistons is transformed into a circular motion which can power the wheels. But let's see this process more in detail by disassembling the engine. The term four-stroke is referring to the cycle of engine operation by disassembling.
Okay, so this is the bigger assembly, and whatever we see after this is the internal assembly. If you checked over here, this is the crankshaft, right? And inside this there are the pistons, right? And these pistons are driven by like these are moved upward and downward with the help of through the combustion, right?
The engine. The term four-stroke is referring to the cycle of engine operation which requires 4 strokes of the piston. First stroke, intake. The valve must be in the open position while the piston pulls an air-fuel mixture into the cylinder by producing vacuum pressure through its downward motion. The air-fuel ratio is generally about 14.7 to 1. That's because fuel cannot ignite alone. It is the oxygen in the air, in fact, that provides the combustion of the fuel. What happens now that the air-fuel mixture is inside the cylinder? Second stroke, compression. During this stage, both the intake and exhaust valves are closed, and the piston moves up the chamber to the top. This causes the compression of the fuel-air mixture, which decreases 10 times its volume. At this point, pressure rises drastically as the air and fuel molecules are compressed together, colliding with each other and increasing the temperature. Now we are ready for the explosion. Third stroke, combustion and expansion. At the top of the compression stroke, the spark plug fires, igniting the compressed air-fuel mixture. This causes an explosion. As the fuel burns, it expands, increasing the pressure inside the cylinder and driving the piston downward, moving the twist that rotates the crankshaft, which will convert the energy of the explosion into rotary motion. Now, let's see the fourth and final stroke, which is called exhaust. During the exhaust stroke, the piston once again returns to the top while the exhaust valve is open. This action expels the spent air-fuel mixture through the exhaust valve. The 4-stroke cycle is complete, but it does not stop here. At a speed of 6,000 RPM, it repeats up to 50 times per second, causing 200 explosions per second inside each cylinder of this 4-stroke engine. More than 10 years in industrial supplies have led JIS
Okay, one more video I have. This is the video with audio. That's why I played this video first. Keep your it's you can see Bosch company. All the components, those are Bosch company, right? Now this engine is a turbocharger engine, right? Turbocharged engine. These are the two different engines. The mixture which this is the exhaust. The previous is the mixture, right? This is the ignition, right? So voltage pulse is applied, so spark happens over here. Fuel is taken from this, right? And air is taken from the inlet. This is the exhaust. This is what a motion we achieve. Now if you observe, the synchronization between these valves and the crankshaft is achieved through assembly, a mechanical assembly. We'll see that we have that inside this video, because there should be a synchronization between this. If it is not synchronized, then it might fail, right? So here we have assembly, right, which synchronize the inlet and outlet with respect to crankshaft, right? So this is the chain which is used to synchronize, right? This whole portion called as railing, common rail, right? So when we start engine, right, a fuel goes inside, which comes through this nozzles. We call this as nozzles. Then air is taken inside, compressed, then they burn. So obviously one more movement is happened. The kinetic energy is converted, the heat energy is converted into kinetic energy. This part moves downside. So this is piston. So there are 4 pistons. You can see these 2 are synchronized and the middle 2 are synchronized. This synchronization is achieved through a belt or through a chain, okay, which is connected outside. The injection of fuel and the air. That is controlled through actuator. Have you got the idea how the engine is driven? Am I audible?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Because our students, electronic students, they don't have idea of IC engines, right? You might have these things in your next subject, right? But our student, they don't have. Basically, in older syllabus, that first year syllabus, we have engine types, right? But I don't know in autonomy we have this subject or not, right? So that's why I shared this video so that some idea will be student can see how exactly the pistons are moved, crankshaft is moved, and how it is synchronized, right? Okay, that's it for today's lecture. Basically, this subject, for this subject, I need a lot of preparation, right? These are the different components. We'll see tomorrow each and every component, right? Now it's easy, no, to understand these components, right? Because in this video we have all those components available, right? Right. Okay, tomorrow we'll continue with same, and then we'll shift to electrical and hybrid vehicle, and how the mobility achieved in electrical and hybrid vehicle through the engines, right? That we'll discuss tomorrow, right? Mark your attendance in chat box. Mechanical, all divisions are here, no? A, B, C, D. Hello?
Yes, sir.
Okay, okay. From computer, any students from computer? One student is there, registered. Hello? From, hello? Yeah. What's your name, please? Your voice is not clear, please. Pardon?
Hello, is it audible now?
Yes, yes, he's audible.
Saurabh Pandey, sir.
Saurabh Pandey. Good, good. From IT department?
Sir, Samriddhi Golghate.
Yeah, yeah. I think 4 to 5 students are registered from IT department. From ENTS, it is 20 students, and from others are from mechanical branch. So for computer and IT, what about the video? You understood the video? Hello?
Yes, sir. Yes, sir.
Yeah. If you want to learn more about the engines, it's better you go to any website, or you just search IC engines, right? Heat engines. You will find these things, right? And the syllabus is not up to the four-wheelers, right? Nowadays, generators are established. Those are installed in various societies for backup purpose. Do you know?
Yes.
Yeah, they also use same engines, right, to generate the electricity. Hello?
Yes, sir. Yes.
Yeah, yeah. So it's better we understand the engines first and how to control that engines, right? Shall I stop now? I think almost attendance is over. Shall I stop? Hello?
Yes,
Yes,
sir.
sir.
Yeah. Thank you. Good day.
Thank you, sir.
Thank you.